in the last video, I showed you me drilling this and fitting it. I don't know if I showed you the run out. I'll see if I got the clip of that. Not perfect. It's got a little wobble. I'm definitely not going to put a... Yeah, I ain't putting a dial gauge on that, because that's going to be ugly. I don't even want to know. The run out was horrible because I drilled a hole that was not actually bored, so I just made the problem worse. So what I did, I'll show you. I'll take this off and I'll show you in a minute. But right now I've fixed the error, or remedied the error, not fixed it completely. So I'm getting about, so there's 0, almost 3, and do we go? But there's 1. So about 4th thou run out. Maybe a little worse on the outside, but that has been chewed up a little bit by clamping it in a vise. So this is the smoothest area, and I'm getting 4th thou run out, which is acceptable. But then after doing all the fixing I did, I realized I need a bigger pulley anyway. So let me show you what I did with this one. Unfortunately, my camera battery was not working, so I was not actually able to film it. So see if you can really see what's going on here. If I can get the camera where I can show you this. So, whoa! What I had to do was I had to overbore this. I believe that I bored it out to 7/8, and then I had to fix my lathe, which I did get it fixed. I had to turn a sleeve. This was this is the 1/2-inch copper water pipe, which happens to have an OD of 13/16. I believe that. Anyway, so it would almost fit in here just perfectly. So I bored this out to 5/8. Then I knurled the outside of this. It was already 13/16, and I knurled it up to. And of course, a knurl is a form tool, so it actually displaces some of the material and enlarges the diameter to 7/8. And then I, just for grins, I put some JB Weld on there and drove that in, and it's solid. It's very solid. And I'm down to only 4th thou. So I mean, I could use this, but the reason I went with this small pulley to begin with, this smaller pulley, was I had a weaker motor. So after all that worked to fit this, now the motor that's required or specified for this pump, I made the decision I probably should go out and buy a pulley that's made for this pump. So this is a 3.5-inch. I could have saved myself a lot of time if I would have realized this at the beginning. That's why it's been a while since I've got between these two videos. I had to wait for this to come in. But this is a 3.5-inch by 5/8 bore. Ooh, that's gonna be tight. There it is. And I bet you that's gonna have less than 1 thou run out. Let's see how good their machining is. I'm sure it's better than mine. Okay. So we'll set this to, okay, if I stop moving the Noga, and look at there, they've got, granted I don't have the key in it, but that's about 4th thou run out on the farthest end. So that's almost, let's see what the middle is. Okay. Stop moving around. Three and a half thou, roughly. Well, almost back to 0. So about 3 thou, which is good enough. I mean, that's plenty. Good enough for what I'm doing. And this should actually give me previously this compressor was putting out about 1,000. It was running about 1,000 RPM. I don't know what the CFM on that was. I have to go look that up. But this should drive it at about 1,200, which is what is recommended at. Oh yeah. So that's the way it would go on the compressor. We'll be around there later, but this will go against the wall, and then flywheel for the pump would also be on this side, be against the wall. So, and the compressor would go in that direction. So this would turn in that direction. So I'm pretty sure that's correct. So I'm going to wire this up temporarily and see and make sure that that's going to turn in that direction. I could be wrong, but whichever way this turns, I'm going to make the other one turn. So that's what I'm going to wire this, and I'll just have the pigtails sticking out. So this is the ground wire, and these are my two hot wires. So I'll just, wire the pigtails essentially, and then it won't be that bad. Shoving a wire in the socket. Okay, come on, Bubba. Come on, it's not quite cutting that. There we go. While I'm doing this, I'll go ahead and tell you a little bit about what 240 volts, or this is actually split phase. Some people might call it two phase. It's not really two phase. It's split. It's what comes into the most homes in North America. It's 120 volts per leg, give or take, plus or minus 5 volts. And like leg A, we'll use leg B. I was just going to say A and B as our legs, 1 and 2. A and B. Leg A will actually use leg B as its ground, because they're running 180 degrees out of phase. So when leg A is high, leg B will be on the. So when leg A is like on the high peak of the sine wave, leg B will be on the same but on the negative side of the zero. So what that means is, one leg, that since they're always opposite each other, they can use each other for ground. So you can actually, believe it or not, 240 volts, I don't even have to hook up a ground to this. This would make this motor run. Very bad idea, because you don't have a ground connected. So if anything happened inside this motor, which this motor is already affected, so I'm going to go ahead and put a ground on it, because I'm pretty sure this motor's got an issue, and that issue may cause the case to be hot with, well, they can only be 120 volts, because if it was 240 it would short out and trip a breaker. But you can't, if it's a perfectly good motor without any issues, which I don't advise without ever running anything without a ground. That's just bad. I had a few pieces of equipment that the ground is broken off of, and I need to replace that plug, because that's never a good idea. But 240, you can run it with just 2 hot wires, because of the nature of that signal. It will use the alternate leg as its ground, return to ground. Okay. And you can also do stuff like my grandfather always did this. He would put in a switch, he would have a big motor like this on his table saw, and he'd have a switch, and he would only switch one leg. And yeah, if it's a 240 volt motor, you can turn off one leg, and yes, it will stop, because it can't see its ground, it can't see its other leg. That is really dangerous, because if you don't know what's going on, he knew it, but us kids would come around and the motor's still half live, and if you got it, if it was something happened inside the motor, you could get a shock from it. I can't figure out how that goes back together. With the key somewhere, I think that's the key. That little tab grounds the shield. Yep, there it goes. So, I thought that was the kind of switch I had. I've got a switch that disconnects this machine from on. And I thought that's what I had. I turned it off before I started pulling this motor off. And I didn't realize it until I was already got a jolt of electricity that, oh, I just wired that with the break of one side, which was dumb. So I'm going to, part of this redo is I'm going to replace that with a double pole single throw switch, so it actually breaks both poles. Now what I did is I went and turned the breaker off, and that definitely turns off the power. But I took the easy way out when I put that switch in, and now I'm going to have to go back and redo that because that is no bueno. Okay. Let's get these connected. I'm just going to put tape on these. I'm not going to actually even put wire nuts, which is a safer thing to do. So this is just a temporary pigtail. I'm literally just going to bump it for rotation, like you would a three-phase motor. I've got in the upcoming video, I'm going to be attempt to explain the three-phase motor, at least how to use a three-phase motor. Three-phase is awesome. I'm more of a gearhead than I am a electrician. But why didn't I strip that? If you're more of a motor guy, a three-phase motor is akin more to a diesel, and just a standard two-phase, split-phase, or single-phase motor is akin to a gasoline engine. By what I mean by that is, most motors are rated, especially single-phase motors are rated at a certain RPM no load. Well, at that RPM, that's where they produce typically that's where they produce their highest torque. Whereas a three-phase motor can generate high torque at pretty much anywhere, depending on how it's driven. When I say driven, by a piece of machinery or by a electrical control. So a diesel engine has its high torque pretty much wherever, but it's torquey on the bottom end. Whereas a gasoline engine has to get up to speed before it can generate a whole lot of torque. So it's kind of analogous if you think of it. If you're a gearhead, in electrical motors, a three-phase is like a diesel. So that's what I'm going to replace the motor on the lathe with. That motor is weird. You catch it on a good day. Really, if you catch it on a good, I don't know how to explain it, what I think it's doing, but depending on where the motor is when you engage you turn the current on, it'll either run or it'll fight itself. And I think it has something to do with the starter windings, or maybe it's capacitor, I'm not sure, but it's just a matter of where it's at when you apply the current, when you turn the switch on. But I've already got a motor, a three-phase, and I'm going to wire it up and I've got to modify the faceplate on this one so that I can bolt the new motor on. And with a three-phase, I literally have a dial. I have a little control box, and I can turn that control box. And I'm probably doing all this talking, you can't see anything what I'm doing. You can control it's a freak drive. You control the RPM of the motor with the frequency that you're feeding it. The only problem with that is, a drawback is, it whines. Because you're feeding it a high frequency, depending on how good your driver circuit is, it generally will produce a whine, and so then that's a drawback when you're trying to film stuff and it's got a high-pitched whine in the background that's audible. But anyway, so got to figure out which way that thing turns. So you're kind of in my way. Just need to reach around the back here, make sure none of that's touching. Okay. So make sure you're paying attention here. You gotta watch which way that thing turns. Fuck it, little bastard. Okay, it's turning that way. Yeah, that's the way. So it's. I guess it's counterclockwise if you're facing the motor. Okay. So I need to mark that before I forget that. I'll do that with a. Yep, that'll work. Now I get to do the new motor over. It's a little bit heavier than that one. Okay. And I think, yep, there it is. Here's where we access the wiring in here. I think it has a, no, the book does. But yeah, it's got a little deal, counterclockwise or clockwise, which leads to connect to. The counterclockwise is what we want. Isn't that right? So we're turning, clock runs this way. I'm doubting myself. So for counterclockwise rotation, we need the two hot wires, one hot wire on terminal 2 and one hot wire on terminal 4. So, no, sorry, I'm sorry. It's always one and no. Okay, red goes to 2, and then the two lines are 1 and 4. So that's the red lead, and that is on. What is that on 2? Well, I could have marked that a little better. Trying with light, I can't see what they're doing. That's definitely the red one. Where's 2? I'm not finding 2. That's 3. That terminal is 3. Which nothing's on 3 for either direction. That one up there looks like it's 5. This one I don't see a number on it. Yeah, so that's. Well, even not without knowing, I know where that came from, so I'm going to hook it up and test it for rotation, and if it's not the right one, I'm going to flip it. Double that cable up just so it fits the connector better. When you're putting these on, you probably already know this, but you crimp, your indentation for the crimp is on the back side of that split. So I actually want to, I'll show you right here. So I'm going to crimp with this guy right here in the middle here. I want the split to be on the downhill side, or the convex side, or concave side. Yeah, concave side. And I want the actual, the convex side pushing on opposite that. That makes it a lot tighter crimp. If you do it the other way and you have the convex side poking on the split, a lot of times it just opens the connector up and makes it a lot loose, it makes it a loose connection, if any at all. Gotta get that lined up on there and mash the crap out of it. So now I've got a little dimple on the opposite side of that, and it's squeezing that in there tight, and there's no shake or anything, so that's good. We're gonna get this working today without a whole lot of theatrics. I don't want any theatrics actually. I don't want it sparking. Okay. So as it's wired, it was wired just like it was from the factory. I don't know how I'm gonna get that fork in behind. There we go. Yeah, that's just not really. A little copper kind of a bowl that they got around it really makes it hard to spin that. Part of the reason I make these videos, and I'm sure there are a lot better sources than my tutelage. Mr. Pete's a great one. Not all kids live, I guess, I mean it's tough for me to think of this, but not all kids have a shop teacher. I took 4 years of shop. I took every year I could in high school. And if you didn't have, if we're not exposed to that, a lot of kids today, I'm afraid, don't know how to troubleshoot stuff. So I'm just adding to the pool of cross references, but I would definitely check out Mr. Pete. I mean, he claims and he bills himself as the YouTube shop teacher, and I totally agree with him. So when people came, Mr. Pete is awesome. Let me see if we can get this motor to spin in the right direction. Also, when it comes to anything electrical, motor, especially motor-wise, Jeremy Fielding. Jeremy Fielding is another awesome YouTuber that you want to check out. So, what we're shooting for, get this down here a little better. We're shooting for this to go that way. But if it goes that way, we got a couple of wires to flip. Get that out of the way. Now make sure you pay attention here, because I may not actually see this. I probably won't see it when it starts, but I'll see it when it slows down. Okay. Oh, I need some longer leads. Okay, contact. Look at that. Turning the wrong direction. Yeah, it's turning the wrong direction. Of course. Come on. Oh. I was trying to plug it in 110. Glad you couldn't see that. Idiot. It's still turning counterclockwise. Okay, now we need a key. I believe that's a 3/16 or a quarter. Key stop. Big healthy key there. And I believe this needs to go in this direction. Just 3/8 of an inch from the motor shoulder or shaft shoulder. So that's going to be it. And then we get to go rewire and replumb it.